Hey everybody, my name is Alex with Hake Hardware, and in this video we are going to go over how to deploy a cluster on Windows 11 using Ubuntu WSL with Docker installed. So there are some prerequisites. You should have gone through the prep disks for WSL. You should have gone through installing Portainer. It's not required, but I use Portainer, and if you want to follow the guide directly, then I recommend using Portainer. It's a great application. You should have deployed your node. You should have deployed NATS. NATS is a requirement for clusters because NATS is how all the components communicate with each other. You should have the latest NVIDIA drivers installed. You need at least drivers 550 or greater if using NVIDIA to GPU plot. I'm not really going to cover AMD because I don't have any AMD cards. I don't really know how to get those working. And then you should install the NVIDIA toolkit for Docker. It's pretty easy. You just are adding the repo, or not the repo, but the packages, the source list, and then you'll do a sudo app update and then install the toolkit and then get the Docker runtime going. And at that point, you're good to go to start getting your cluster set up. So let's jump over to Windows. And the first thing we're going to do is just make sure we are aware of where our disk paths are and what size they are for our farmer. So I'm going to right click on the start menu here. I'm going to go into terminal and then I'm going to go into WSL. So we should already have Ubuntu set up with Docker. And I'm going to paste in this command here. If you followed my guides or used my mount point, you should be able to find your disks pretty easy by running this df block size equals G. So since my path where I mounted my drives has Autonomys in it, then I can just easily pull those paths out. So when we go to set up our farmer, we're going to need the path and then we're going to need the size. And typically how I do it, and the left side should be the size that you're looking at, this left column here. This is in gigabytes, and when we go into our farmers and specify the size, we're going to be doing it in gigabytes, and I just subtract 1. So I've actually already set these disks up. So the disk size is 127 gigabytes, and I specify 126 gigabytes, so the right column is the disk space used. And this is, I think they like round it up probably, but I only have like 1G or 2G left over. You can technically try and get even closer to full usage, but I found that 1 gigabyte really isn't going to make much of a difference. So just keep that in mind. You can keep this up actually because we'll come back and copy and paste this so it's easy to reference. But once we have that, we need to now create some folders. So the cluster needs to store the controller data, which has like the identity file and some other important files. So you're going to want to create a folder to store this information. And then you also need to create a folder for your cache. So when you're running just a regular farmer and not a cluster, the piece cache is stored on your actual farming disks. So there would be 1% of this disk reserved for the piece cache by default, which means you'd have like 12.7 gigabytes of that disk dedicated to the piece cache. Now, or actually, I think it's like would be 1.27 stored for the piece cache. So you'd lose 1% of that disk, which for the most part isn't a big deal, but one of the benefits of the cluster is you can move that piece cache off the disk and you can set it to whatever size you want. And for fastest plotting, you're going to want to have a piece cache, or just we can just call it a cache, that is as large as the current blockchain size. So let me actually bring up a website, which is kind of cool that I've been looking at. Let's jump over to our browser here. So the current blockchain, the archived history size is 95.75 gigabytes. And when you're plotting, you're basically plotting this archived history. And as it grows, you have to replot and do, sectors become stale. So you're going to have your initial plotting, and then you're going to be replotting periodically as the archived history grows. But when you're doing your initial plotting, you're going to be using a lot of this history, and that history gets stored in your cache. So if you can have a cache that's like 100 gigabytes, then you're going to have the full archived history basically in your cache, and you can plot very fast. Now, as we kind of mentioned earlier, with this setup, I only have like 3 or 4 gigabytes of that cache, which means there's going to be a lot of misses where it's looking for a piece that is not cached, and then it has to download it on the fly from up here, and that could take a little while. So it's going to slow down plotting. Now, the trade-off, or I guess what makes this not matter as much is when I have a small disk like this, it doesn't matter. It's going to plot pretty quickly, like with the 3080 Ti, which is what I have hooked up to this. This would plot like in an hour or something. So it's not that big of a deal. But if you're plotting like, let's say, 100 terabytes, then you want to have a cache size that is at least the size of the blockchain history, so, or the archived history, I suppose. Uh, so all of that to say, we can now specify a cache folder or a cache drive. Let's say you have an SSD. Technically, the cache can be on a hard drive as well, but you're going to want it to be at least like a decent hard drive that has good transfer rate. Uh, so in this example, I'm going to actually specify a smaller cache when we get to deploying our cluster, but we do need to create the folders that we're going to store this data. So I'm just going to copy and paste this command I have. What this does is it makes a directory. -P just means if a subdirectory doesn't exist to just create it. So I don't have this Autonomys folder yet, but it's going to create the Autonomys folder, then create the cache subfolder, and then also create a controller subfolder. So we've got that set up, and if I do ls, we can see we have that Autonomys, and then we have nats from earlier. And now we need to set the permissions because our Docker container needs to be able to read and write to this. So we're going to do sudo chown, so change ownership -r to nobody and no group. That just means that Docker will be able to have access to it. And then for every subfolder under Autonomys, so cache and cluster. Put in our root password here. And we can verify this with ls-l Autonomys, and we can see now that the cache and controller are owned by nobody and no group. All right, that is it for the command line. Leave this up though, because like I said, you're going to want to reference your disk paths here. And we're going to bring up our browser, and we're going to go into Portainer. And then I'm going to go into my environment here, my local environment. I'm going to go to stacks, and I'm going to add a stack. And this is going to be my Autonomys cluster stack. Now there's a few ways that you can go about deploying your cluster. In fact, there's like 1,000 million infinite ways you could deploy your cluster. For me, I'm going to deploy it, all the components basically on one system that's also running nats and also running my node. So if I just open up a new tab here, you can see I have my, I'll just go to containers. I have my node running, that's on 172.100. I have nats running 172.101. And then of course I have Portainer running. So everything's local, which means I can reference certain things locally by their names. So if I go into stacks and I go to nats, I can see my service is just called nats. And if I go into node, my service is just called node. So what's cool about when you do all this locally is you can, instead of putting in the IP address like 172.25.0.100, I can just put in node. And you're going to see this will become more clear when we actually create the stack file. But just know that if your node, let's say, you've set up your cluster on one host and now you're setting up like a plotter that you want to add to another host that's going to join the cluster. When you're specifying nats, you're going to have to use whatever computer's IP that's running nats for the IP, not the name nats. And let's just get into this because I think it'll be easier once you see it. But the first thing we're going to do, there is a link to a cluster file, and that will give you a template to start with. So we'll paste that in here. You should be able to just click it. And what this has is every single component. So we've got the cluster component, we've got the cache component, plotter, and farmer. Now there's a lot that we need to update on this. So let's copy So a little copy icon up here. Go over to our stack file in the web editor, paste it, and what we're going to do is start from the top and go down. So some of this you're going to need to update. The first thing is the image. Right now, Mainnet 2024, November 06. We can Google Autonomys subspace and find the latest. So right now, this is the latest version. If there's a newer version, you should update it. And as you can see, you're just updating this second half here with whatever is in the releases. And you can click the releases and see, you can just copy it here and basically paste that in. The next is we are going to be doing what's called a bind mount. So from our Ubuntu WSL instance, we are mounting this path here, which easy way you can get this path, let's say you go back to your terminal and you go cd autonomous, we're doing controller, hit enter, then you can do pwd or print working directory, and that's going to be the path to your controller. So you would just copy that. Now it's, because I built the templates, it's already where it needs to be for me, because I always, for all my computers, put the controller here in my home directory. And then on the right-hand side of this colon, that's what you're mounting to your container. So inside your container at /controller will be this directory that's been mounted. So next thing we're going to do after you update that is go down to NAT server. Now this is what I was talking about. I have just NATs written here, and that's actually referencing 172.25.0.101. So that's where I have NATs, but because it's all on the same network inside Docker, I can just do NATs. For you, again, like if you have another host that's hosting your NATs, you would have to put the IP address of that host in there. Okay, for labels, if you, oh, actually we missed, here's the node. Same thing with the node. It was 172.25.0.100, but because it's running on this autonomous network that I created in Docker, I can just reference it by its service name, which is node. Otherwise, I could do the IP address, but it's just easy when I have it local to have it listed like this. Okay, this is actually, you can either delete this entire labels if you want to. This is for Spaceport, which is a custom monitoring application I'm working on. If you want, you can just leave it. It's not really going to affect anything. And if you ever do run Spaceport, it'll have this nice name that gets imported here. Update your time zone to whatever time zone is applicable for you. And then you can leave the rest as is. Let's go down to the cache. Cache is the same idea. Make sure you have the same version. Make sure you're on the left side of this colon, you're doing the working directory. So if you go back again, cd dot dot, cd cache, and then pwd, it should be the same. You're just changing controller for cache. And let's see. Okay, so NATs, it's the same thing with NATs. You'd update the IP address if you need to. And here's where we specify how big we want our cache. Now, I'm only going to do 5 gigabytes because this is just a demo and I don't have a lot of space on this disk. I only have like 100 gigabytes, so I couldn't do a lot if I wanted to, but you're going to specify the size you want. And remember, you want it to be ideally as big as the blockchain history, or the archived history, basically. So right now it's 100 gigabytes. If you have a lot of space that you need to plot, then I would make it as big as you can. And then, and you can specify it as like a disk. So if you mounted a disk somewhere, you could change this and be to wherever you mounted a disk that you want to hold the cache on. It doesn't have to be in your home directory like I did it. Labels, same thing. Time zone, same thing. Okay, we're into the plotter now. Image, make sure it's updated. NATs, make sure it's updated. Time zone, make sure it's updated. Labels, same thing as before. Now, this is where if you don't have the NVIDIA runtime, which was specified in the prerequisite for the NVIDIA Docker Toolkit, this section right here, this imports your GPU. So if you didn't do that step, you're going to get an error that it doesn't know what NVIDIA runtime is. So that's basically, if you're not running an NVIDIA GPU, you can remove this and it will just use your CPU to plot. All right, the farmer. Now this is where we are going to be referencing our disk paths and size. So we'll go through just like normal, make sure the image is updated. Then at the volumes, this is where we're bringing in our disks. So I'm actually going to go over here. I'm going to copy this disk path. Then I'm going to paste it on the left-hand side here of the colon. And then on the right-hand side, this is the folder that I want it to be mounted to inside my container. I have two disks, so I'm just going to copy this, press enter, and make another copy. Go in, copy my next disk. And if you have like 20 disks, yes, this can get tedious, but luckily you only have to do it once. Copy this, paste it here. Okay, so this disk is set for importing the volumes. Down here, make sure NATS is good. Update this with your reward address unless you want to give me your rewards. And then now we need to specify for the farmer, it needs to know the size. We're going to use the path that we mounted it to up here, but the size we need to specify based on what we saw in our command line. So the first thing I'm going to do is update the path. So for the first disk, it's going to be that first drive. And I'm just going to copy this again, just like you did at the top. Make another one because we have two disks. And I'm going to use the same part here. There we go. So we have our two disks. Now we need to put the size. So remember, it's 127 gigabytes. I'm going to put 126. And they're both the same size. 126. So now we're going to be mounting our drives to inside the Docker container at this location, and then we're specifying to our farmer that at this location we want to do a 126 gigabyte plot. Update your time zone. Labels you can delete or update as needed, and then we are importing our autonomous network, so it's going to be running on the same network as everything else. Now at this point, we can go ahead and launch. So let's hit deploy the stack and see if we get any errors. And if you get errors, it's not a problem. You can fix it pretty quickly. Okay, so we are deployed. It goes to the stacks thing. So we're going to click our autonomous cluster. First thing I always check is controller. Controller looks good. It connects to NATS, connects to our node. Everything is looking good. Now this is just going to sit and wait for all the other components to connect, which they should shortly here. So let's go back and let's check out the cache. Cool. Cache was created and we can see we've got some elements here. Everything looks good. It's connected to NATS. No problems there. So let's go back and let's check our plotter. Okay, everything looks good. We connected to NATS using CUDA GPUs. It says used CUDA devices is 0, which might be like, okay, it's using 0 devices, but no, this is the device ID 0. And since it starts with 0 for the counting, I guess, it means one GPU was added. And you can see that CPU plotting was disabled because the GPU was detected. So by default, that CPU is going to be disabled. And then we'll check the farmer. So it does look like the farmer is looking good. We can see let me turn off auto refresh here. So we can see NATS was connected. We can see the farm was found, so 126 gigabytes at the directories that we specified. And now it's going to start plotting. Now this is a little misleading. It's not really going to start plotting. It's going to say that it's plotting, but the first thing that needs to happen is the controller needs to synchronize the piece cache. So remember when we were talking about the cache, it's the archived history. In order to plot, it needs to populate that cache first. So what it's going to do is start downloading, and I only specified, I think, 5 gigabytes, which means it's only going to download 5 gigabytes of the archived history, and then it will start plotting. So we're not going to see any progress on our plotting, and there's going to be a percent that gets printed out here, like 5% done, 10% done with downloading the piece cache. So just keep in mind it's not broken if it doesn't start plotting right away. In fact, I think I just saw, yeah, so we can see 0% complete. It's going to be increasing that over time, and it can take some time to download the piece cache because it is a large size and you're downloading from peers, and if you get bad peers, sometimes the download is slow. You can always try restarting your cluster if it just like stalls, but typically it's best to just leave it, let it go. There's some more advanced things you can do, like creating more connections. There's additional flags you can set in your container, but that's beyond the scope of this tutorial. So at this point, everything is looking good. Yeah, so you're just waiting basically, and you'll see the plotter starts to get these plot requests, and it'll begin plotting as soon as that piece cache is synced. And if you go back to I have this Autonomys files, which is where we downloaded the cluster GPU separate. There's a bunch of different things. So if you just want to deploy a cache or a controller or a farmer or a plotter, there are different YAML files here. So let's say I've got, this local host running a full cluster, got all 4 components, and I just want to add in my gaming computer, which maybe has like a really nice GPU, and I want to connect it to my cluster so it can help plot. Well, you can set up Docker just like you did on this host and get everything running except for you can skip a lot of steps. So you only need one NATS instance, and you only need one controller, you only need, one cache, although it's best to have a cache located on the plotting computers because you're going to be sending a lot of data back and forth if the cache isn't co-located with the plotter. There's some inefficiencies there that I hope they fix, but anyways, if you want to set up that plotter, you just only need to run the plotter container. You don't have to run the full cluster on every single computer. You don't have to run NATS on every single computer. You would just update NATS to the internal IP address of whatever host is running NATS, and then you'll be good to go. So there's a few different things here. There's also cluster GPUs combined, so you can theoretically run the farmer, the cache, the cluster, the plotter, everything on one container. This is not great because I like to actually like deploy and restart things. Like sometimes I have to restart my farmer because I, add a new disk or something. You can't just restart the farmer, you gotta restart like the whole cluster. So I prefer to break it out and run it separately, but you could, let's say you only plan to run everything on one host, you could run everything on just this container here and it's probably going to be fine. So it really depends on your situation, what you want to do. I try to put example files for as many like configurations. I still need to do the plotter with cache group. Maybe it'll be updated by the time you watch this video. I'm not really going to go into like cache groups and stuff, but it goes into like if you want to have caches on multiple hosts and you want to kind of have a controller and a cache be together, like you can specify a cache group. So that's going to be it for this video. Hopefully it was helpful and you're able to get your cluster running. If it was helpful, please feel free to leave a like. If you have questions, you can either ask in the comments or join my Discord. There's links on my YouTube page, and I'll see if I can help you out. I am definitely not an expert, but I'm trying to make as many of these guides just to help people out. But if you do have questions, I'll help out as much as I can. That's it for this one. I'll see you in the next one.